Okay, hello classes. As you know, I am not here. I am currently on Kairos. I am not taping this at Kairos. Believe me, I'm not even thinking about you. Anyway, what we're doing is I want to make sure that you guys are cool for the quiz and that sort of stuff. It's been a 4-day weekend, so let's just really quickly recap what we got, what we're going to be doing. So, on this particular quiz, certain things. There's only one equation. The only equation at all is the force of a charge is K Q1 Q2 over r squared. Okay? Remembering that this is the constant K 9 times 10 to the 9th newtons meter squared coulomb squared. Okay? What are we going to be doing with this equation? Well, we're going to be doing a couple things. One is we're going to be talking about what happens if you change some of those variables. If we take a look at the review, let's go and head down to take a look at this. You can see like 12. It says a separation distance. Well, remember, table your data. R, 0.5 meters. Okay? Two like charged balloons experience a repulsive force of force is 0.32 newtons. It now says the distance is doubled. Okay? Then what's the repulsive force going to be? Remember how we did these before when we had gravity, and we would sit there and just use the equation and put stuff in to figure out what's going to happen to it. So I'm going to put in the equation and leave a little bit of room like we've done before. Q1, Q2, r squared. So it says the distance is doubled. So if I put 2 there, that's going to be 2 squared. Okay? Which means it is going to be 1/4 of whatever the 0.32 happens to be. Okay? And you're going to be ending up about a 0.08 type thing. In fact, I'll tell you what the number is currently as I look at, 0.08. So you have 0.08 newtons. Okay? This guy is the same sort of trip. Once again, F equals K Q1 Q2 over r squared. It says separation of 5, so you just put the stuff in. And this will tell you if you need to actually use the equation or you're just looking at the relationships. Force, oh wait, that's the same as the last one. But now what it's doing, it's saying the distance is increased by a factor of 3, and you're going to square that sucker. And the charge on both is doubled, so that's going to be 2 and 2. Whoopsie. 2 times 2 is 4. 4 over 3 squared, that's going to be 9. Multiply that by the 0.32 newtons, you get your answer. And on that particular one, it's 0.142 newtons. 142 newtons. So this is going to be one type of problem. One type of problem is where you're just going to be given the equation, and then we're talking about relations that exist between them. Remember, charge is directly proportional, and then you've got the inverse square for the distance, just like we had with the before when we had the gravity type stuff. All right, but what happens if you have something where you have a problem? Actual mathematicus. Not a problem. You sit there and go. I'm going to change out my pen because this guy is poopy magoopy. Okay, so charge, QA, attractive force. So you sit there and go, cool. Force equals 1.5 10 to the second newtons. Okay? As a result, the QB, second charge, located the distance, 2.4 centimeters. Remember, you want to make that meters. 4 meters. Okay? And then it says QB has a charge of 5.2 10 to the negative 6th coulombs. Okay? So you go, all right, I'm going to go force equals K, QA, QB, could be 1 or 2, over r squared. I know the force. I know K, it's a constant. I know this charge which is there, and I know that guy there. So I can just rearrange the equation, and I know I'm going fast. But what happens is the person that's doing this, you can just tell them, hey, turn it off for a second so we can talk about it, whatever it takes. So I'm going to take the r squared, bring it up. Okay? And that's going to be K, QA, QB. And now I just go and take these guys and divide through. So I go force, whoop, radius squared divided by k times the QA. Yes, QA. I'm sorry, QB, because we're looking for QA, is going to be the QA. And then you just plug and chug. Boom, 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 boom. Plug and chug and get that. Okay? Coming down here. Let's go take a look at this guy. Two objects are located along the x-axis. Object A has a charge of positive 25 microcoulombs times 10 to the negative sixth, and it's located at the origin. So we go, okay, cool. Here's A, QA, which is positive 25, 10 to the negative sixth coulombs, because that's a microcoulomb. B, and it's located, this QB, not quarterback, just QB, excuse me. There's the QB. And here it is, and this guy happens to be negative 16. Remember, we are not worrying about the charge right now. The positive and negative is going to be directional. Okay? So object B is going to be here. Distance is going to be 0.62 meters. Okay? Magnitude and direction, it's just like we did before with the equation. Except when you actually get it, okay, we want the force of A on B. So what is the force of A on B? So B is the one we're interested in. Give it a little circle. And notice, that's going to be a positive charge. That's a negative charge. Opposites will attract. Therefore, this guy, the force is going to go that direction. So it's going to be left when you get your eventual answer. I'm not going to worry about doing the math right now. You guys can figure it out. And there's that force equation, or force, I should say, arrow, which happens to be there. All right, so that's one thing. One thing is going to be the equation and what's happening with the equation. Other things are going to be just general charge stuff. So things like a formally neutral object just lost electrons. Hey, if you lose electrons, you're going to be positive. These, I think, shouldn't be too tough. Let's take a look down here. 7. 2 uniformly charged spheres are firmly fastened to and electrically insulated from frictionless pucks on an air table. The charge on sphere 2 is 3 times the charge on sphere 1. Which force diagram correctly shows the magnitude and direction of the electrostatic forces? Okay? Well, first thing we need to know is this. Positives. If they're both positives, that means they will repel. So this guy, bye-bye, because it should be repelling. This guy, bye-bye, should be repelling. This guy doesn't know what the hell they're doing. Get rid of it. Okay? Should be doing something. Now you take a look and you say, all right, what about the force charges? Okay, the forces that you get from these charges. See these arrows? They are not equal. See these arrows? They are. That's the one you want. Remember, for every action, there is an equal and opposite reaction. Remember, we were talking before when we were talking about forces. We were talking about the fly getting hit by a train or a truck. Who gets hit harder? Fly by truck or truck by fly? Turns out, the same. The forces are the same. So make sure that you remember those arrows are the same. All right. You might get something like this. Negatively charged balloon brought near a metal can. Draw it. Okay? So here's your can. Boom. Okay? And you bring a negatively charged balloon. Hello, balloon. Remember, if that guy is negative, what is negative saying? He's saying, electrons, get out of here. That's what this guy is saying. So that means the electrons are all going to move to this side, leaving the positive charge on this side. Recall what's called? Polarization. It's become polarized. It's still neutral, but polarized. Now it says the side of the can opposite of the balloon is touched. So I touch this thing. Boom. That's my finger. This guy is saying, electrons, get out of here. Electrons, get out of here. So the electrons are going to move out. So these electrons are going to move out. Okay? That means that this can now has a net positive. So let's say we have 2 negatives left and we've got all these other positives there. It's a net positive, okay? So it's going to be positively charged. By the way, if it doesn't touch, we call it induction. If it does touch, it is conduction. Conduction, always the same charge. Induction is going to be the opposite. This is what we did with the electroscope, if you guys recall. Take a look at this guy. An electroscope is negatively charged with the leaf at an angle of about 45 degrees. Doesn't matter. A rod is slowly brought towards it. Okay, so you start out. Here's your before. Because these leaves are leaving, that means it must have same charge because it's repelling. Now, you bring in, okay, electroscope is negatively charged, so that means it got a bunch of negatives. That's why they're repelling. Now you bring something towards it, and the leaves come together. Well, that means that these negative charges, which are there, okay, and I should have said they're more bundled up at the bottom, are bundled up at the bottom with the positive charges up here. That's how you sort of started it. Now what happens is you bring this guy over, and the leaf falls. Well, if the leaf falls, that means the negatives are no longer all hanging up in here. The negatives must be moving up. Well, if the negatives are moving up, what kind of charge is going to make that happen? Positive. So they're going to get attracted to the positive. So it's going to be positively charged, not uncharged. It's going to be positively charged. All right. A couple more, then we'll be done with this particular guy, and you guys are going to get a little bit of time just to sort of go over these. So let's review just real quick. Remember, we're going to have the equation. You're going to have charges, how charges affect things, like balloons, that sort of stuff, electroscopes, etc. All right. Take a look at this one. Negatively charged balloon will be attracted to a neutral wooden cabinet. So here's the balloon, there's the cabinet. Due to polarization, which of the following diagrams best depicts why this occurs? Well, remember, if it's polarized, that means this is neutral. So it's positive and negative, just equal numbers. That's why this guy goes out. Only negatives. That's why this guy goes out. Only positives. That's why this guy, well, let's take a look. Ooh, it has positives and negatives. This guy has positive and negatives. No, that guy goes out. So now you go between the ones that are left. What does negative do to negative? Repels. Not that guy. Negative, up. There it is. That's the one that you want. Okay? So, what you guys are going to be doing now is you're going to take a few minutes. You're going to go over these different things. If you need part of the video replayed, the teacher can potentially do that for you. So right now, though, you guys are going to take a look. These are the types of things we're doing. Good luck on it. I'll be coming back.